Now we are going to start a new chapter, chapter 7, and we'll be focusing on compounds. First, we'll be looking at the formulas and the names of compounds, and then we'll move on to the mathematics of compounds. We'll be starting with the formulas and names of ionic compounds, and to do that, we're going to learn about ions. Now, we've already learned some things about ions, but we're going to review that and extend that today. All right, so we know for ions we can have monatomic ions or polyatomic ions. So let's review that. So a monatomic ion is a single atom with a charge. A single atom with a charge. So if we have an atom with the same number of protons as electrons, that atom is neutral. But if our protons and electrons do not equal each other, then we have an ion that has a charge. So our metal atoms are the ones that lose their valence electrons and become positive ions. They lose their valence electrons, the electrons in the outermost occupied energy level, and become positive ions. So, for example, magnesium is Mg, the neutral, but when it loses its electrons, it becomes Mg2+. So magnesium is 2 valence electrons, it loses those 2, loses 2 negatives, and becomes 2 positive. And the name of this is just the same as the element. We just name this the magnesium ion. And our metal atoms are cations. All right, our nonmetal atoms then, always the opposite of metals. Our nonmetal atoms, they will gain electrons into their valence shell. So outermost occupied energy level, and become negative ions. All right, so for our example, if we have nitrogen, nitrogen has 5 valence electrons, it's in group 15. It wants to have the octet, so it's going to gain 3 electrons. So it ends up with a 3- charge. Now remember that for negative ions, negative monatomic ions, the name ends in IDE. So this is the nitride ion. So if we have an atom of fluorine, the name is fluorine. If we have an ion, it is the fluoride ion. And then our nonmetal atoms, when they become ions, are anions. All right, so metals lose valence electrons, become positive, they're cations. Nonmetal atoms gain electrons, they gain to get the octet, and they become negative ions called anions, and their name ends in IDE. All right, our other type of ions then are polyatomic ions. And a polyatomic ion is a group of covalently bonded atoms with a charge. So this is a group of covalently bonded atoms with a charge. we have compounds, the entire group acts as a single unit. The group acts as a single unit, and we'll be seeing that when we do our formulas and nomenclature. Our polyatomic ions can be positive or negative. We have cations or anions. So example, we have NH4 with a positive charge. This is known as the ammonium ion. And we have SO4 with a 2- charge. And the name of this is the sulfate ion. And we'll be looking at these later on in this lesson. So now we need to get the periodic table that you printed out. And we're going to make a periodic table of ions. So I'll just cross this out, of ions. And we're not going to do all the elements, but we are going to do some of them. So first, I think it would be a good idea to kind of mark off where that staircase is, because that is going to be very important in this. So just kind of mark off that staircase. And for what we are doing now, we're just going to be splitting up our elements. So to the left of the staircase, we're just going to call those the metals, except for hydrogen. Hydrogen is an exception. Hydrogen is a nonmetal. To the right of the staircase, we'll just consider them nonmetals. And we know that we have metalloids along the staircase and germanium and antimony under the stairs. But for this, we're just going to split it at the staircase. All right. So for our ions, we're going to start with our group 1 metals. So group 1 has 1 valence electron. And when those elements form compounds, they lose that valence electron and become +1 ions. So we can go ahead and fill in all of our elements with charges. So we'll leave hydrogen for later. Hydrogen's an exception to a lot of different rules. So we have lithium with a +1 charge, sodium +1, potassium +1, rubidium +1, cesium +1, and francium +1. So if we have an ion, a metal, in group 1, it's always +1. Go to group 2. Group 2, they will always be 2+ ions. So we have beryllium, 2+, magnesium, 2+, calcium, 2+, strontium, 2+, barium, 2+, and radium, 2+. Okay, we're going to get to these in the D block, our transition metals, but first we're going to move over to here, and we're going to do our metal. Here we're going to put in aluminum. Aluminum has 3 valence electrons. Aluminum will be a 3+ ion. Okay, our noble gases don't form ions. Helium has 2 in its outermost occupied level. That level is full, and the rest of our noble gases have the octet, so they're very stable. They don't form ionic compounds. All right, our halogens all have 7 valence electrons. They only need 1 to be like a stable noble gas in terms of electron configuration. So each halogen gains 1 electron to become an anion. So we can fill in that column. So F- fluoride, Cl- chloride, Br- bromide, I- iodide, At-, I guess it's acetide or something. We won't be using that. And we don't really know the properties of some of these elements down here, so we're just gonna kind of stop there. All right, So we are now doing our non-metals that become anions. So for group 16, we're going to go up to the staircase. We're just going to do our non-metals, not the metals at this point in time. So all of these non-metals have 6 valence electrons. They gain 2 to become like the electron configuration of a noble gas. So we have O2 minus oxide, S2 minus sulfide, Se2 minus selenide, and Te2 minus telluride. Okay, right here, group 15, these non-metals, they have 5 valence electrons. They're going to gain 3 to be like the noble gas in their period. So we have N3 minus nitride, P3 minus phosphide, and As3 minus arsenide. All right, carbon and silicon, they usually are in covalent compounds, so we won't worry about them at this point. Okay, now there is something known as the slide. So aluminum in group 13 has a charge of +3. Slide down catacorner to our element. If you look on your periodic table, we can see that is zinc. Zinc is always a 2+ ion. And if we slide down again, catacorner, and look at that element on the periodic table, that is silver. Silver is always a +1 ion. So this is called the slide. +3, +2, +1. All right, now I want to show you something before we start filling in some of these D block metals and these P block metals. So now we're going to be concentrating on positive ions. And there are 2 types of metals. So we are going to look at our type 1. Our type 1 elements. Only these are metal. We're just looking at metals now to the left of the staircase. Our type 1 metal elements. They only will have a single charge in compounds. So they only form 1 cation. So all of the metals that we've done so far are that type. The lithium ion is type 1. The aluminum ion is type 1. And everything that we've done so far on the table for our metals is type 1. But we also have a type 2 metal elements. And these elements form 2 or more cations. So that includes our D block elements that we haven't done yet and our P block metal elements. So we're going to take a look at how this happens. Where does this come from? So we're going to take a look at iron. Iron's our D block element. So if you look at iron on the periodic table, it is element 26. So if we have a neutral iron atom, it will have 26 electrons. And to do our noble gas electron configuration for a neutral iron atom, so we go to the noble gas closest to iron, but less than that in atomic number, or the noble gas before it on the periodic table. And we have argon, and then we follow, and we have 4s2. And then remember, our D is always 1 less than the period number. 3D, 1, 2, 3, 4, 5, 6. 3d6. That is the electron configuration. Now, sometimes in compounds, iron will have a charge of 2+, meaning it has lost 2 electrons. So it will only have 24 electrons. It will still have 26 protons in the nucleus, but only 24 electrons. So our electron configuration for that is argon. Now, what electrons is iron going to lose? When we put them into the atom, the S goes in before the D. However, when electrons come out of the atom, the electrons furthest from the nucleus come off first. So these 4s2 electrons get lost, and we end up with argon 3d6. Now, in some compounds, iron becomes a 3+ ion with only 23 electrons. So it has one less than this ion. So now it takes an electron from the 3d. So our electron configuration is argon 3d5. As for the names, we have to distinguish between these two ions because they are not the same. This is a big difference when we have a difference in charge. So Fe is the iron atom. Fe2+, we say, is iron, and we put in parentheses and we indicate the charge with the Roman numeral. So this is iron Roman numeral 2 ion. And this one then is iron Roman numeral 3. Okay, so we're going to put iron in our chart. So go back to your periodic table of ions and count over and find where iron is. So 1, 2, 3, 4, 5, 6. So iron is right here. And what we're going to do is just put a little slash there, and we'll put in our two different charges. So we have Fe2+ and Fe3+. Okay, so all of these metals are type 2. They all form ions with different charges. So we're not going to go through the electron configuration for each one of those. We're just going to go ahead and put some of them in our chart, certainly not all of them. So let's find out where tin is. So locate zinc, go over 2 and down 1. Yeah, okay, so that's tin. And tin forms +2 ions and +4 ions. So this would be tin Roman numeral 2, and this ion would be tin Roman numeral 4. Underneath tin is lead. Lead does the same thing that tin does. We can have Pb2+ in some compounds. In other compounds, we will have Pb4+. Tin Roman numeral 2, not tin, lead Roman numeral 2, lead Roman numeral 4. Next to zinc, we have copper. Copper sometimes is a +1 and sometimes is a +2. So silver here is always +1. Copper can be +1 or +2. So Cu+ or Cu2+. All right, all of the ones that we haven't filled in yet, all of our metals, they can always be +2. So the only ones here in D block that can be +1 are copper, that is sometimes +1, and silver, that is always +1. The rest of them can be more than one charge. So we'll just do a few of these. So titanium will either be a +2, tin Roman numeral 2, or a +4, Ti4+. Now, and that's all we'll do for now, but we could fill all of these in. How are we going to know which ion it is? Well, tomorrow we'll learn how to find that out. We'll either be able to figure it out from the name of the compound or from the formula of the compound. Okay, so you want to hold on to this. You'll be using this a lot when we do our naming of ionic compounds. Okay, so the last thing on the agenda for today is to look at some polyatomic ions. So you were asked to print out the polyatomic ion chart. And this is one of the benefits of e-learning, is that you will always be able to use this chart. Now, if we had a regular class, we were in school, you would have to memorize this. And believe me, that is not easy. So you can be grateful for at least one thing for having to stay home, is that you do not have to memorize this chart. Okay, so it gives us the formula for the ion and the name for the ion. So we only have two positive ions, the ammonium ion that we mentioned earlier, and the mercury 1 ion, and I think we're really not going to pay attention to that one too much. All the rest of the ions on the chart are negative ions. So most polyatomic ions are anions. So our first polyatomic ion is hydroxide, and we only have 2 atoms, but it is still polyatomic. And we're going to want to keep those parentheses there when we're writing our formulas. And it has a -1 charge. Now the next two, we have nitrate and nitrite. Whenever your name ends in ate or ite, that is telling you it is a polyatomic ion. And we're going to see that anytime you have an ate or an ite, it's got oxygen in the formula. And there's a relationship between the ite and the ate. The ite here has 2 oxygens, the ate has 3. The ate always has 1 more oxygen than the ite. All right, then underneath we have sulfate, sulfite, and thiosulfate. So our sulfite has 3 oxygens. The sulfate has 1 more oxygen. Permanganate, MnO4 with a -1 charge. And then we have 4 ions involving chlorine and oxygen. But if we look at the chlorite and the chlorate, the ate has 1 more oxygen than the ite. Per means we have even 1 more oxygen. And hypo means we have 1 less than the ite. And we have carbonate and bicarbonate. So they differ in their charge and their formulas. Chromate and dichromate. Phosphate, phosphite. So the phosphite has 3 oxygens, the phosphate has 4, -3 charge. Here we have an anion that ends in IDE. It is polyatomic, 1 carbon, 1 nitrogen with a -1 charge. And then for acetate, there are 2 different ways to write the formula of the ion, but these are the same. We have 2 carbons in the first way to write it, and we have 2 in the second, 3 hydrogens, 3 hydrogens, 2 oxygens, 2 oxygens. So for acetate, it doesn't matter which way you write them. I usually write it as the bottom one, but sometimes when you're doing organic chemistry, it's more helpful to use the top form. All right, so tomorrow we will learn how to write formulas and the names for ionic compounds.